Welcome to this lesson on solving quadratic equations by factoring. In the next few lessons, we're actually going to really be exploring different ways to solve quadratic equations. Obviously, today's lesson's on factoring. At this point, we've talked about graphing. Today, we're going to talk about factoring. Some other methods that we're going to be discussing in the future is how to solve quadratic equations by using square roots, by completing the square, and by using the quadratic formula. So as you see, there's a lot of different methods, and as we go through this, I want you to think about some of the pros and cons of each method. For today, we're really focusing on factoring though. Before we begin, let's talk about some pros and cons of this method. Some pros of factoring, of solving equations using factoring, is that if you're really good at factoring, this is going to be nice and quick for you. This might be a really nice, easy method in order to solve quadratic equations. A second pro is that this really helps to keep your factoring skills fresh. As we move forward through algebra and in your future math classes, factoring is going to show up a lot. So being able to manipulate these expressions and factor them out is going to be really important as you move forward through your math career. Some cons of factoring is that not all equations will be factorable. We've dealt with expressions in our last unit when they were not factorable, and when we dealt with an expression that wasn't factorable, we called those prime. Unfortunately, when we're dealing with equations, we can't just say it's prime though. So if we have an equation that's not factorable, you're going to have to use one of those other methods that we just discussed in that previous slide. Another con is that you might be dealing with an equation that is factorable, but you might have some really large numbers to work with, right? And that's okay, but that can be really time consuming. So if you have some really large numbers to work with, you're going to want to use another method. All right, and we've really talked about those other methods, and we're going to be discussing those as we move forward through this unit. So let's review. When we solve equations by factoring, we're going to go back and apply that zero product property that we talked about in our previous unit. The zero product property states that for every real number, a and b, remember we're focusing on real numbers, not imaginary, if a, b equals 0, so if the product of a and b is 0, then we know that a must equal 0 or b must equal 0. Or a and b are 0, right? That makes sense. If the product of two numbers is 0, then either that first factor must be 0, that second factor must be 0, or both of them must be 0. When we apply the zero product property in today's lesson, this is really going to help us figure out what our x-intercepts, our roots, or our zeros are. So this visual to the right, obviously I just kind of threw up here in a quadratic function over here, and we see that those roots, remember those roots are where that graph intercepts the x-axis. So when we use the zero product property, we're going to take whatever our first factor is and set it equal to 0, take our second factor and set it equal to 0, and that's going to give us our roots or our x-intercepts, all right? Those are our solutions to our quadratic equation. So let's talk about steps of factoring. And throughout today's lesson, you're going to be applying each of these steps. The first thing you want to do is to set the equation equal to 0. So if it's not already set to 0, you have to set it to 0 so that way we can apply the zero product property. The second thing we're going to do is to factor the equation. So you're going to take a look at that expression on the left or the right, and you're going to factor that expression using what we know from our last unit. Step 3 is to apply the zero product property, right? Set each factor or each part of my equation equal to 0. Step 4, always important to check your solution. I know some of you like to skip that step. Please don't skip it though. Check that solution, plug it back in, make sure it makes sense. All right, so on your notes, I actually have example 1 already filled out. So we're going to go through this and just remind you guys how we actually solve an equation using the zero product property. In example number 1, we're presented with the equation quantity x plus 5 times the quantity 2x minus 3 equals 0. Now, this equation is already set equal to 0. It's actually already factored, so this is really nice. We're going to go straight to step 3. In order to solve this, I know that if both of these factors is equal to 0, like if they're multiplied together and they're equal to 0, then I can take that first part, x plus 5, set it equal to 0. I can take that second part, 2x minus 3, or that second factor, 2x minus 3, and set that equal to 0. And now we have two equations that we can solve out. So x plus 5 equals 0, I solved it out to the left, and we get x equals negative 5. On the right, we have 2x minus 3 equals 0, I solved that out, I get x equals 3 halves. those are my roots of this equation. So my solution in set notation, and this is what we're expecting you guys to write, is negative 5 comma 3/2. What this means is that if I kind of graph this quadratic function, this should intercept at negative 5. Ooh, sorry, I don't know why I did that. This should intercept at negative 5 and 3/2, okay? And I just kind of showed that really briefly. All right, so those are my roots. That's where it's intercepting that x-axis. All right, let's move on. So let's look at example number 2. In example number 2, we have 2x squared minus 6x equals 80. Now, our first step is to put this in descending order, or in other words, standard form. So in order to do that, I'm going to move everything over to one side of the equation so I can have my equation set equal to 0. Now, it doesn't matter which way we move it, but in my, for this, I think it's easier to move the 80 to the left. So I'm going to be left with 2x squared minus 6x minus 80 equals 0. Step 2 is to factor this equation. Before I do, I'm always going to double check to see if I can pull out a GCF. Hopefully you didn't forget that, right? So I look at all 3 of my terms and I realize that my GCF here is 2. So I'm going to factor out that GCF. So 2 times the quantity x squared minus 3x minus 40 equals 0. From here, now I'm going to factor this expression, x squared minus 3x minus 40. So I bring down my 2. I'm going to set up my 2 binomials, all right? And now I'm going to start filling this in. I know my first numbers here must be x, and then I'm asking myself what 2 numbers multiply to get me negative 40 that add to get me negative 3. That's right, 5, positive 5, and negative 8. Okay, so hopefully you got that correct. From here, we're going to set each part of my equation equal to 0. So if I said 2 equals 0, right, that's my first factor, this isn't true, so we can actually just disregard that 2. My second equation I'm going to set up is x plus 5 equals 0. And my third equation I'm going to set up is x minus 8 equals 0. When we solve that, we get x equals negative 5, and we get x equals 8. All right, so the roots of my equation are negative 5 and 8, and I write my final solution in set notation in numerical order. Now, when we check our work, we're going to apply that negative 5 back into my original equation. We're going to see if that actually equals 80. And to check, we're also going to plug in x equals 8 back into my original equation and see if that equals 80. Okay, and it does in this case, so we're great with example 2. So the roots or the solutions of this equation is negative 5 and 8. Now in my head, if you need that visual, right, this means that this quadratic function is hitting at negative 5 and positive 8. Okay, those are my roots on the x-axis. Beautiful. Let's move on to example number 3. So in example number 3, we have x squared minus 11x equals 0. Now it's already set equal to 0, so in this case, I'm going to see if I can factor my expression on the left. I see that my GCF is x, so I'm going to pull out that x, and we get x times the quantity x minus 11 equals 0. From here, I'm going to set each factor equal to 0, so x equals 0, x minus 11 equals 0, applying that 0 product property. X equals 0 is one of my solutions, and then I solve x minus 11 equals 0 is equal to x equals 11. So my final solution is 0, 11. All right, and we can leave our answer like this. Visually, if I'm kind of thinking about what this quadratic function looks like, it's telling me that it is crossing at the origin because my x-intercept's at 0 and at 11. So this one also has 2 solutions. All right, let's move to example number 4. If you'd like to pause the video and try this out on your own, you absolutely can, but let's actually go through this together if you'd like to still stay with me. All right, so negative 24m plus 144 equals negative m squared. I notice this equation is not set equal to 0, so I'm going to think about what's the most efficient method to get this equal to 0. Remember, it doesn't matter which way we move that negative m squared or either expressions. In this case, I'm going to move the negative m squared to the left by adding m squared on both sides. We're left with m squared minus 24m plus 144 equals 0. From here, I'm going to factor this expression. We should notice that this is a perfect square trinomial, right? Oh, bringing back all that good stuff from our last unit, right? So we left with m minus 12 squared equals 0. Now from here, in my head, I'm thinking, all right, this is the same as saying m minus 12 times m minus 12 equals 0. Using that zero product property, I have two equations, right? M minus 12 equals 0 and m minus 12 equals 0. If I solve this out, I get m equals 12, m equals 12. Now in this case, we have a repeated root, right? And we don't need to list both of them. So my only solution here is 12. All right, and what that means is that we only have one point in which this equation crosses that x-axis, and that's okay. This is just one solution. So this is crossing at the x-axis at 12, 0. All right, that x-intercepts at 12. All right, so we've got some skills-based examples 1 through 4. Now let's move on to an application problem. We're going to talk about how we actually can apply some of this solving by factoring into an application problem. So let's read this together. Number 5, it states, the diagram shows a pattern for an open top box. The total area of the sheet of material used to manufacture the box is 288 square inches. Now the height of the box is 3 inches. Therefore, a 3 by 3 square, or therefore 3 by 3 inch squares are cut from each corner. All right, so the visual on the left shows us really nicely kind of what's going on here, right? We have our total box here, and I'm just going to trace that in red. This whole thing has an area of 288 square inches. All right, and then after they actually make the box, they're going to cut out those 4 corners that are 3 by 3 squares. All right, so let's think about how we're going to solve this. The first thing we need to know is to figure out kind of what's my length and my width. Well, if I know this length is x plus 2, and I'm adding 3 inches here and 3 inches here, this total length must be what? Good, x plus 8, right? We have the x plus 2 plus 3 gives me x plus 8. So that's going to be my first factor, taking my length here, x plus 8. Now I'm going to take a look at my width. Well, if this portion's x, and once again, this length is 3 and this length is 3, what's my total width? Correct, x plus 6. All right, so I'm going to take that and I'm going to multiply it to the quantity x plus 8. So I have my length times my width should give me my area, right? And in this case, what is the area of my full box here to the left? That's correct, that's 288. All right, so we've created an equation that represents the area of this box or this diagram shown to the left. To solve this, though, we are going back to those factoring rules. The first thing I need to do is to have this equation set equal to 0. Now, I can't just move the 288 to the left yet. I'm taking a look at that expression to the left, the x plus 8 quantity times the quantity x plus 6, all right? And I'm going to say, well, we have to FOIL or double distribute that. So we're going to do that. We have x times x, which gives me x squared, plus 6x plus 8x gives me positive 14x, plus 8 times 6 is 48, equals 288. All right, so now we're kind of getting closer to that equation we want. From here, to get this equal to 0, I'm going to move the 288 to the left, and I'm left with x squared plus 14x. 48 minus 288 is negative 240, is equal to 0. Now we have that equation that we like to see, right? From here, since it's set equal to 0, we're going to now factor this expression to the left, all right? So I'm going to set up my two binomials, set it equal to 0. I know this is x, I know this is x. Now I'm asking myself what two numbers give me 240, multiply to get me 240, that add to 14. All right, if you need to do some guess and check work on the side, that's totally fine. All right, I come up with 24 and 10. Now I know the negative must belong to the 10 and the positive must belong to the 24. All right, from here I'm going to solve each equation and apply that zero product property. I have x plus 24 could equal 0, x minus 10 could equal 0. To solve this, I get x equals negative 24 and x equals 10. Now in this case, it looks like we have two solutions. However, in the context of this problem, I know my x can't be negative, right? I can't have a negative dimension. So I'm going to now eliminate the x equals -4. Because if I plugged the x equals -4 into both of these expressions to the left, x plus 2 or x, I can't have negative dimensions. It doesn't make sense in the context of this problem. All right, so my solution here really is x equals 10. But that doesn't answer the question. They're saying find the dimensions of our box here to the left. So let's kind of erase our work here. Now if x is equal to 10, I'm going to plug that in. This means this x is 10, this length is 12, and we know our last dimension is 3. So the dimensions of this box is a 10 by 12 by 3, and then it's inches. Okay, oops, that's a little messy, I'm sorry, let me erase that. So that's the dimension of this box. All right, so hopefully this video helped you on solving quadratic equations by factoring. At this point, you're going to complete some practice problems, really reinforcing some of those skills. Definitely refer back to those steps as you guys are going through those examples. Thanks for watching. I hope this